So I would regard this research project as a highly interdisciplinary and collaborative. So nowadays, to solve the grand challenge for the agriculture and environmental problems, just a single discipline is not enough to tackle the grand challenge. So converging the technologies, expertise from different areas like agricultural science, plant pathology, and geography, geospatial technologies are very important to develop the integrated solutions, for the problem solving. So through this collaboration, so we can find out, there are so many opportunities to develop the innovative technologies and the solutions, plus potential tools that can help our farmers to tackle these plant pathogens.
So my name is SCN Liu. I'm PhD in environmental resources and policy. So my role in this project is to collect data and bring in data to analyze the data and find the methodology to early detect these soybean diseases. So this is the drone we have been using for the field study. The drone is mounted with multispectral cameras. So this camera can capture red, green, blue, and red edge and near-infrared band. So the images captured can be stored with this flash drive. And this is the calibration panel we use to calibrate the brightness of the camera we have been using. This is a controller we have been using to control our flight. After we collect the data from the field, we bring in the data to the lab and stitch all those images in Pix4D software. After stitching the images, we calculate the vegetation indices.
My name is Joseph Moses Kalinzi, currently pursuing a Master's in Science of Geography and Environmental Resources. What we see on screen are the snapshots which are taken by the drone. The different points that you see are the points that the drone takes as it is flying across the field. What happens, you set up the flight height, then the overlap size, and then the speed of the drone, which once the drone flight goes up, it follows the flight path, the flight plan you've set for it, and then as it goes through the path, it takes the snapshots that we see of the field, of the study field that is down here. And at the end of the flight, we receive these images and stitch them to get one solid image. And so, since the drone is a multispectral, it means it has more than one band. The current drone that we have has 5 bands, which is the blue band, the red band, the green band, near infrared, and then the red edge band. And so, when we combine these different bands, we come up with what we call vegetation indices. And different vegetation indices show different relationships of the activity that is going on. So, from the previous trials that were done last year, we looked at 36 vegetation indices, and the 3 top ranking were NDVI, the normalized difference vegetation index, then we had NDRE, and we had EVI. And so, for this season, what we did when we took the drone flight, we were able to get the different bands which I've talked about, and right now what you see is the NDVI image, and what you see, these are the different plots of the soybean plots, and these are the tracks for the irrigation tractor or irrigation device. Then these are the rows or the aisles separating the different plots. So this is the NDVI index, then this is the NDRE index, and this is the EVI index. What you will see, there are different representations, and so when we study the relationship of the indices combined with the ground truth, the cyst count, and then the yield count, we shall be able to find the relationship, how the different indices relate to the cyst count, relate to the yield that comes from the different plots. And that way we shall be able to get the equation which shall be used to develop the system.
So we've had two good flight years with data. One of the things that we found in these last 2 years is that when we take samples from the field, the amount of cyst nematodes on a single root system can exceed 80 females just 45 days after planting. That bit of information is not really tracked that well in terms of the greater region. We're not going out and doing root digs necessarily on cyst nematode across the industry. Again, we take soil samples at the beginning of the year, at the end of the year, but we're missing that key component of what's going on in those very initial stages of a nematode reproduction. And so that's one of the key findings that we had is like the overwhelming number of nematodes that are attacking the roots, and then the virulence in that population is really striking to us. Even though we've been watching this for years building up, it's still surprising even to the scientists.